will do this presentation. My name is Pieter Pauwels. I will do this. I'm affiliated with Ghent University, also TU Eindhoven. I will do this mainly from TU Eindhoven. And in Eindhoven, I'm doing this from the EASY Institute, which is a weird acronym saying Eindhoven AI Systems Institute. So it's an AI Systems Institute. And I would like to give a bit of a talk about two main projects that we do in Eindhoven. One of them is Brains for Buildings, which is a Dutch funded project. And also Walter is involved in that, or was involved in it. And the second one is one that we have internally in Eindhoven, which is about robot navigation side buildings. That's just our own project. We'll try to do a bit of a technical details from here to here and there. So to give you some insights on how things actually work, or at least how I think they do work. This is one of the buildings that we have on campus. So what we would like to do, and what many presentations today have been looking at also in the morning, is that we have our buildings. This is a picture of the Brains for Buildings project. This is the building that we have on campus. And we would like to have our data about this building available as a digital twin, and ideally in two directions, meaning we want to connect back into the actual building, so the physical twin, and control some of its systems. How do we do this? So this is something that has been developing over so many years now. I would like to give some ideas on it. So we don't want to do it only now, like a snapshot. We want to do it over time. So we want to do it. This probably does not work in the history. So for heritage and for short time history, but also in the future, we want to make sure that we have data available that is available for renovation projects, for example. And also during the construction phase, which is kind of a separate environment where you have very quick exchanges between lots of contractors, engineers, architects, lots of modeling, lots of issues. But then after that, you have a bit of a more slower exchange, which is more the facility management and operational phase. And from my perspective, I would like to do it without file-based exchange. So that's kind of a personal liking. So we'd like to do it live as much as we can, so that we have direct access. I think we're used to our phones by now, our iPads, tablets. We have all systems available at our tip of our fingers. Wouldn't it be nice if our BIM models are also just there to see the data of our buildings? This is leading to what we are all working on, namely building information modeling, digital twinning, predictive twinning, and also our linked data approach, which is something I like a lot, obviously. So we want to make sure that all our data is kind of getting out of those 3D models, made available for asset managers, and we can connect it to the time series and sensor data and control applications, for example. Which is not easy. It's not easy. This is a picture that I took over from Building Smart, so the previous organization, and that's, I think, 3 years old. So that was the IFC roadmap of Building Smart. It's changed by now, probably. And yeah, before that, we used to have lots of the elements on the left. So you probably in the back, you can't see it probably, but it has IFC doc, it has MVD, it has IDM, it has IFC Step Express. If you go to the right, you can see more XML, JSON, linked data, which is a different word for RDF, and then APIs, more APIs, IDFs. And actually today we are more or less getting there with lots of input from some Dutch people, such as Leon. We're actually getting closer to a more web-oriented Building Smart, I think, which is good. So I think that these organizations are moving towards the web, where you can see more of those other file formats which are easier for developers to work with. And this leads to these, to give you an example, this is the example of the semantic graph, so the RDF linked data. I try to always explain it with this onto-text visual graph, because it's the only visual manner, otherwise you are stuck with text, more or less. So you can easily explain that our building consists of a graph of nodes, where you have a building which has multiple stories. Every story has multiple spaces. Spaces are contained by walls. You have properties, etc., etc. I think most of you know this. So we can actually explain our assets quite easily as a graph, and then it is visually relatively clear. It's one of the key things about those graphs. The other key interesting part is that they all have these URIs, the web-based identifiers. So instead of this GUID, which you recreate with every IFC export, you have a URI that says, this is it. You will look it up on the web, and there will only one page returning, which is the identifier of this asset. So that's the ID. That's one of the key mechanisms of our RDF semantic graphs. So what we see both in the linked data environments, but also in Building Smart, I think, and just in general in our projects, or all the work that you guys are doing, is that we're more moving into a data sharing and a live data access environment rather than an information exchange, file exchange process. So I made a very abstract picture here a couple of years ago, where the red nodes are individual servers. They say, okay, so or buildings. So I think that it would be nice if the future would have buildings with their own digital replica or their own server, which where you can find the information about this building, hosted by the building or the owners of that building, and managed and maintained by them. So it's kind of distributed, decentral. Not a huge central Google-like cloud that says, here is all the data of the Netherlands. These two distributed to all the building owners. And the idea is that you have then these data access interfaces, I called it, so you can query every building for their data over time. And I think many of us are moving in this direction, which is fine. So we're arriving, I think, at the cloud of live building data and infrastructure data, if you like, which is really exciting. I think it's really nice that we have this. Which items are we then working on next to actually continue? Because we can say we have this cloud, which we still have to make it happen. And what you can see in reality is that these graphs are only a part of the deal. They're not everything. So the graphs that I showed, they're actually not even in the picture, maybe on the left, bottom left. There you have the graph about that says this is our building. It has these assets, it has these properties, but you also have the OGC data, so the GIS data available top left. We have the sensor data streams in the middle. We have seen plenty of this. We have 2D drawings. We have on bottom right is also sensor data. We have different kind of geometry. We have point clouds. Clearly, we can't put all of this into a graph. It's just it doesn't fit. So we have a whole bunch of data available, which is more than our semantics that we have in the BIM models. And I tried to categorize it, and I came up with this. I came up with the slide before this, and then I said, oh, this is still missing, this is still missing. So I added more, but I can see there's like two main streams that I look at, which is the data streams on the top left, and then on the bottom left is semantically rich and interconnected data. There's lots of terms there, you don't have to look at them. The idea is that you have data streams, IoT streams and so forth, sensor values, temperature values and so forth. That's a sort of data. On the other hand, you have these semantically rich data, which is categories, properties and so forth. And you have slightly different implementations. And if you look at the computer scientists, you will typically find the difference between the data scientists and the information modeler. The data scientist using lots of statistical AI, the other one doing lots of databases and symbolic AI. So those are two different breeds. One almost died, but they're still there. So we have two different kinds of computational techniques that we can use for the different kinds of data, and they need their own data sources. So if you give the semantically rich data to a machine learning expert, he will say, oh, I don't know what to do with this. Strip all the semantics, and vice versa. So they have their own added values. So we need to support them being stored for our building. So if you have a smart building or brains for building, the way in which we try to look at it now in our project, I always want to point, it's not possible. So it's that we have in the bottom, we have a data store, which allows the semantically rich data, so graph databases. And on the middle, we have the data lakes, which is more streams, IoT streams, for example. On the bottom right, you also have the control systems, which is a whole other dimension. And then on top, we have this more of a system integration. So rather than looking at the data integration, we're now looking more at system integration across multiple systems. This has the great added value that we can also do security, because that's managed in this integration layer, or at least on top of your database. So we're now looking, and then on top, those icons that look like washing machines, they're actually applications, or a very bad icon for it. Those are different applications using the data that is available below. And this kind of works. So we're looking at this for this Brains for Buildings project. This is the same building that was in the picture on our campus, where we are basically annotating the building using the brick ontology and also all of the other ontologies. So there's also haystack and there's also bot and so forth. And the idea is to then link it using those ontologies to your sensor data. And then in the next slide, I'll skip this one, you can see that we have, it's not that difficult to build an interface where you have the 3D model, you click on the elements and you actually see this room has these sensors getting the sensor data stream. And with that sensor data stream, we can do the machine and then do predictive maintenance, which was the previous presentations. So honestly, I think that works quite well. That's not it. So that's just one part. So that allows you to do this smart buildings applications. What would be nice if it scales further up and it gets more generic. So the idea, that's something that's not in the slides, it's once. So we try to use a second application using the same data set, and that was the robot navigation. So we wanted to do robot navigation inside buildings. Why? Well, because we had the robots, we had the buildings to some extent. So, but we want to test it. There's lots of applications that you could look into. Anyway, it's also trying to see if you can connect to the same repository for a very different case and still use it. And that was actually presented by those two researchers 1 year ago or 2 years ago, standing next to each other at different tables, showing on the videos of the two applications in parallel, which is really nice. So the idea is that we have these robots and we want to navigate through the building. And okay, my slides are out of order. But so what we do here is that we take the same cloud that we had, which is this graph, the semantic graph. That's the slide by Jeroen, it's in the back there. For every URI in this graph, we have a number of geometry representations. This is rather straightforward in the linked data approach. You have multiple geometries. Matches is also left, I think. So you can attach the point cloud data, but also the mesh data and stat data, whatever you like, to that graph. We have done this for this building, and that basically allows us to build a 2D map. That's what the robot uses for the navigation. So the one on the left, on the right, that's the metric map. On the left, you have the topological map, which is straightforward using a BIM model. So those two are generated. And the idea is that you can then say to a robot, navigate to the kitchen and get me a glass of water or anything else. That's application area. I'll try to, and that then actually works. So and the nice thing, I mean, it's just a robot that navigates in theory, and then the robot can navigate in multiple ways. For example, normally it uses the SLAM approach and it uses the point cloud. In this case, we want to accelerate it by saying, connect to the BIM model, to the building, ask for the data, and then you can already start without having to scan the entire building first. So it's a bit faster, or that's at least the idea. And the nice thing is that it again uses the same data set, so we can connect directly to the digital twin and navigate. So we had a small pipeline, which in this case used JSON. We had multiple approaches here. The other research really liked JSON and PostGIS, but he ended up again with this network where you can see in the blue the geometrical reference points, and in red you see the IFC components. So when the robot navigates, it's the straight line. It will measure and it will recognize certain features using the point cloud scanner, and it will say, okay, I am now I think I am now seeing those dots. You can see the dots in small green on the screen. Those are mapped with the 2D data from the server, and then it says, well, this should be a row, or it should be a column. It should actually be this column, and those two are kind of connected. That's the idea. This is kind of now running. There's a couple of weird things. Well, my BIML is not correct, like 98% of BIMLs. Here we're now looking into trying to fix the BIM model from the input from the robot. That would be helpful. You can see there's obviously furniture in the way. These are things that we need to work with, which we are willing to try and go ahead. And that's it. This robot walks around for a while, and it uses the same data sets. I will skip this last part for my last slide. So in conclusion, what do we take away from this? These are two happy projects, I think. And we just tried them. On the right, by the way, you see the reference architecture that we used. The future is now. I think we're in the future. And so we are doing this web-based distributed digital twinning. It's becoming a reality, not only here, but also in all the projects. I think that's really nice. We can do high-quality data storage and also access it. I think we're getting more mature in it. The good thing is that we have those multiple interfaces to one digital twin system. Those are small things, but I think they're very useful things, very useful steps to getting there. What is in the future? What is not there? Yeah, the scalability. How well does this scale across large organizations with security risks and operational demands? That's a challenge for the industry in case. And the second one is the 3D modeler challenge. This is all very nice, but there's no geometry edited. That's some whole other level. So that's also a challenge that I think would be useful to address. I have no idea how the time is. I hope I am time. Thank you.